started with some geometry. We're going to be talking about arc lengths and the fact that the length of the arc intercepted by an angle is proportional to the radius. Okay, so let's do some key vocabulary words we're going to need. So first we're going to talk about the sector. So it's going to be any way you want to divide up this circle, is the inside that is going to be the sector. So any piece of pie here that you decide you want is going to be the sector. It could be out here or it could be in here. And right now we're going to talk about in here. All right, so let's go ahead and define arc. So in this sector, the arc is going to be what is right on top of the circle, right? The line of the circle. So that is the arc. The radius is going to be the measurement from the middle to the circle itself. So that's the radius. And note that this is also the radius, right? But we're just going to label this one. And lastly, the angle is going to tell us how far this line here is going to be from this line, right? It's just a measurement. And we usually measure angle in degrees, but we can also measure it in radians, right? And when you hear the word radians, it should kind of remind you of the word radius, right? It kind of has a similar sound, right? And that's not a coincidence. It has to do with the fact that a radian is going to measure this angle based on the proportionality of the angle being with the arc and the radius. So it's going to have, let's have this radius here, and let's say it has a length A, and it's going to measure, it's going to see how many radius lengths are going to fit into our arc, and that's going to be the measure of the angle. Okay, so since the angle is proportional to the radius and the arc, we can measure the angle based off of that. So here, let's say we have A here, and we're going to flatten it onto the circle to fit into the arc. Okay, so let's say that is also length A. I feel like this is a little longer. This is also length A. And if you notice, our arc here is going to be a little smaller than our radius length, right? So it's going to be less than 1 radian in this case. All right, and it's important to note that if you had all the radii covering this circle here, like this, the angle will be 2 pi. This angle would be 2 pi. So if you lay down each radii on the circle, you would have an angle of 2 pi. All right, so, and here, for our one, it's just going to be here, and it looks like it's going to be a little less than 1. All right, so we're going to go ahead and use that information to find the arc length. So the arc length, here, let's do an example. Find the length of CD. So this is CD here. Always locate what you're looking for. If the radius is 5, so here, 5, and the angle is 2.07. So again, this arc length is proportional to the angle and to the radius. So we're going to go ahead and do arc length is going to equal the angle and the radius. So that's going to be equal to 2.07 times 5, which is going to be 10.35. So that is the length of our arc. So that means that if you notice, there's going to be 2 radius and a little bit more that are going to fit into that arc. Okay, since it's 5, since the radius is 5, and our main one is 10.35, which makes sense with this 2.07. So there's that relationship. Okay, so let's keep going. Now you're going to try, so you're going to find the length of CD. So locate CD if the radius is 23. It's important to note and remember what I said, that the whole circle, the angle is going to be 2 pi. Okay, go ahead and try. All right, so hopefully you got 18.7 for that answer. Now, I want you to try to think about how would you go about solving for arc length in radians, in terms of radians, if the angles are in degrees. All right, well, have a good rest of your day. See you next time, class.